Good morning and once again welcome to my YouTube channel. Today we'll be discussing about arithmetic sequence, IGCSE topic number 3, and of course we'll sail through to example 9. And we are on page 53, and I want to say something that when the difference between any two consecutive terms in a sequence is the same, when the difference is the same, the sequence is called arithmetic sequence. So arithmetic sequence is a sequence formed when the difference between any two consecutive consecutive term is the same. Arithmetic sequence. For example, if we have 2, 5, 8, 11, and moving forward, you realize that 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3, then this qualifies to be arithmetic. It's an arithmetic sequence. So this one is now an arithmetic sequence. If you may have another one, for example, starting with 5, 3, 1, minus 1, and all that, you have 3 minus 5 is negative 2, 1 minus 3 is negative 2, minus 1 is negative 2. Again, the difference is the same, and therefore we are talking of this one being an arithmetic sequence. And of course, in example 9, let's talk about example 9, so to speak. Show that A and B are arithmetic sequences. And we'll start by A. Show that they are arithmetic sequences 5, 8, 11, 14, and moving forward. All we need to show is that the difference is constant. I mean, 8 minus 5, second term minus the first term is 3, that term minus the second is 3, fourth term minus third is 3. So this is same difference. And if the difference is the same, then this one is an arithmetic sequence. Let's go to part B and have 21, 19, 17, 15. Second minus first, 19 minus 21 is negative 2. 17 minus 19 is negative 2. 15 minus 17 is negative 2. Again, we can see same difference. So even this one is sincerely an arithmetic sequence. And of course, we need to go further and find out if it is an arithmetic sequence, what do they have in common? At that point, we can now start talking about notation. What is this? How do we note? Letter A, we talk about term 1, term 2, term 3, term 4, all the way until term N. A is supposed to mean term 1. And because the difference is the same, we call this same difference, what do we call it? Common. We call it common difference. Common difference, or D. So if you want to get from the first term to the second term, you must now add the d, because term 2 minus term 1, just like we got term 2 minus term 1, is the common difference, is d. So to get to term 2, we can only talk about it as a plus d. And because the difference is common, from term 2 to term 3 is term 2 plus the common difference, which is a plus d, which is a plus 2d. And this one is a plus 3d, because term 3 plus d. And I want us to just look at it this way. Term 1 has no d. Term 2 has only one d. Term 3 has 2 Ds. Term 4 has 3 Ds. So term 10 is going to have 9 Ds. And term n is going to have n minus 1 D. The position of the term has differences, or the common differences, one less that particular position. For example, term 1 has 1 minus 1 d, 0d. Term 2 has 2 minus 1 d, that is 1d. Term 3 has 3 minus 1 d, that means 2d. Term 4 has 4 minus 1 d, so 3d. So term n has a plus n minus 1 d. And that is how we denote term n. Term n can mean anything. Term n can mean anything. And at that particular point, I would want us to just explain arithmetic sequence. An arithmetic sequence is given by a plus d plus all that, all the way to the very last term, term n. So the sum of a sequence is given by term 1 plus term 2 plus term 3 plus term 4 plus blah blah blah, all the way plus term n. And how do we go about this? A plus d plus a plus 2d plus a plus 3d plus blah 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 plus a plus n minus 1 d. That is term 1, term 2, term 3, term 4, and term last. We are going to see how this one is executed in example 10. So let's talk about example 10 now, and I don't know whether we are able to talk about example 10 in this particular setup, but yes, we can. And we say, in example 10, find the nth term of the sequence, the nth term of the sequence. Find the nth term of the sequence 5, 8, 11, 14, 17. It goes without saying that the common difference here is 3, because 8 minus 5, 3, 11 minus 8, 3 is 3. Of course, a, the first term, is 5. So term n is a plus n minus 1 d. So how do we get term n? How do we get term n? How do we just get term n? It's going to be, yes, a is 5 plus n minus 1 multiplied by the common difference, which is 3. And this one is 5 plus 3n minus 3, which is 2 plus 3n. And that is the formula for getting term n. 3 plus 2 plus 3n, or 3n plus 2. The second part of this question is asking us, use your answer to part A to find the 100th term. Term 100 is going to be equals to what? Term 100 is going to be, again, because term n is given by this, 2 plus 3, n is 100, which is 2 plus 300. and the 100th term is 302. That is the 100th term. Part C is 243 a term of the sequence? That is the question. Is 243 a term of the sequence? To answer this question, 243 must fit in this formula. If it doesn't, then it is not a term in the sequence. So we say, can 2 plus 3n give us 243? And because n is a position, it has to be a whole number. Positions are 1, 2, 3, 4. So it goes without saying that 3n is 243 minus 2, which is 241. And if this is true, then divide both sides by n. We're going to have n is 80 and a third. And 80 and a third cannot be a position. We do not have a position 80 and a third position. And since n is not an integer, then we can easily say 243 is not a term in the sequence, is not a member of the sequence, is not a member of this very sequence. Therefore, we have been able to find out a few things. I know I will be able to explain this further, but anyway, that is it for that particular example. Let us follow up and see what happens later. All right.